I am Rhonda Young, so I'm a faculty member here in civil engineering and the current chair of the department. Civil engineering really is a field made up of subdisciplines, and sometimes it can feel kind of like a broad, sort of disparate field, but really what unites all of civil engineering is this idea of civil infrastructure and serving sort of civilization. So we have this kind of overriding thing about public health and safety and sustainability in the environment. So most of the presentations will be talking about these five subdisciplines that we're focused here at Gonzaga on. But just a few things, some quick facts about our program that we're particularly proud of. We, as a school, have a really high study abroad rate, and that includes engineering students. And that is unusual because a lot of times engineering programs, it's difficult for study abroad to work with an engineering curriculum, but we've really focused on making that happen. We have very strong relationships between the students and faculty because of the size and the sort of passion and dedication of our faculty. And what's also nice about the faculty that we have is that it's a really good blend of people who are practicing in the profession, have practiced in the profession in the past, and who are also research active faculty, so who are forward thinking and thinking about where the profession is going. So they bring a lot to the classroom with that. We are an engineering program that is very much grounded in the overall mission of Gonzaga. So it's not just the how of engineering, it is the why. Why are we trying to solve these problems, and how can we make the world a better place? And then I just pulled a few numbers that are common numbers that students and most likely their parents are pretty interested in, but how our students are doing in terms of internships. So 90% of our students have at least one internship. Many of them have multiple internships by the time they graduate. High job placement, or students who are seeking to go on to graduate school. And we do very well in what's called the Fundamentals of Engineering exam. So national pass rates for civil engineers are usually in the high 60s or 70s when you look at all programs in the nation, but we have been doing quite well in this. And this engineering exam is the first path to being a professional engineer.
So my discipline of focus is environmental engineering. And so I'm one of two faculty of environmental engineering. We do have another faculty member, Dr. Breed Dory. And so environmental engineering is really about applying physics, chemistry, and microbiology to protect public health and the environment. And so I want to give an example of how we might apply these different theoretical fields to that end of protecting public health and the environment. So before coming to Gonzaga, I worked for an environmental consulting firm called Corona. We don't have anything to do with the beverage company or the coronavirus for that matter. What I will say though is that environmental engineers do address things like coronavirus. So we try to disinfect water to remove viruses and pathogens. I also just developed an in-class exercise for my environmental engineering juniors that are developing a solution to how we can mitigate coronavirus from being spread in the environment. Okay, so the example I do want to give was from my time working on developing solutions at drinking water treatment plants. So here we're looking at a drinking water treatment plant and then the distribution system that sends clean treated water to people's homes. And so we got hired to help out this water system deal with something they called the black water mystery in the news. And so it was called the black water mystery because when water would leave the water treatment plant, it would exit very clean and drinkable. But for some reason, as it passed through the distribution system, it would leave people's taps looking black. And so we investigated why this was the case, and we found that their distribution system pipes were very corroded, and metals would leach, things like iron and manganese, and turn the water black. And so this is where the chemistry comes into play, because chlorine can be added at low levels into the distribution system and react with the iron and manganese and cause it to precipitate and actually stick back on the pipe walls, making the water clear. And then this is where the physics comes into play. We found that they were adding chlorine in their water treatment plant, but because of the way that their hydraulics were set up and the mixing conditions, that the water wasn't getting effectively chlorinated. And so we simply changed the outlet location as well as added in channels or baffles to cause the water to mix with the chlorine. And then this led to the water leaving the tank chlorinated. And this is how we solved the black water mystery. So a combination of chemistry and physics. And so while I don't actually build bridges, but we do have faculty that do that, I think this is an example of one way I try to bridge the theory in the classroom to the real world. And so, as was brought up earlier, I think this is something that makes our program really distinct, in that we have faculty that not are only experts in the theory and performing research to stay relevant in theory, but we have lots of real world experience and can bridge that theory to the real world in the classroom. And so I'll just touch on real quick some of my research interests. I'm interested in sustainable water treatment, like using something called biochar. That's a filtration material that can remove cancer-causing compounds from water. It's a sustainable material because it can be produced from waste materials. So something like waste wood, we can convert it in something called a pyrolysis chamber to convert it into this filtration media. Also, when people produce heat or energy from biofuels, like this local company to Spokane called Ag Energy, they also produce biochar as a byproduct of producing energy from biofuels. And so I'm working over the next year on a senior design project to determine if the materials they produce as a byproduct is also effective at treating drinking water. And then the last thing I'll say too, our faculty are interested in ways we can apply our different disciplines to support low income and middle income communities. So biochar can also be produced in these types of systems that are used to currently produce charcoal in low income communities. And I've studied ways that we can produce simple systems using just waste materials like food cans to produce biochar. And we found this to be effective in being integrated into simple systems where people might store their water, where they don't have access to clean water. And so it can remove these types of cancer-causing substances, even in kind of these low-income regions where water is especially polluted.
I'm Mark Mazinski. I'm a civil engineer and I specialize in geotechnical engineering. When we think of what geotechnical engineering is, we have to think about what is attached to the ground. So everything that you can think of, every structure, every facility is somehow attached to the ground. And that's where geotechnical engineering comes into play. So we're talking about bridges, any types of buildings, towers, tunnels, roads, retaining walls. When we think about what's included with geotechnical engineering, sometimes I use as a synonym soils engineering or foundation engineering, but it includes a lot of geology, rock mechanics, and soil mechanics. The word mechanics in this context refers to how these materials, rock and soil, behave when we put a load on them. So that could be footing from your house. It could be if you drive your car on the ground, what happens to the ground? Or when you're walking on the beach, do you leave a trail or does the ground support you? Now, also in geotechnical engineering, we have to think about all of the other subsets of civil engineering. So that would include environmental, structural, water, transportation. And another one that we sometimes forget about, but it's still there, is the construction considerations. And that's what my talk has to do with a little bit, geotech and the construction. And so when we think about the trajectory of a civil engineering project, we plan, we design, and we construct the project. We have to think about what happens in the middle, though. A lot happens right here. And what's happening is making it all come together. And so in addition to all the subdisciplines, there's a lot of project management too, and that's related to the construction end of it. Some of the skills that I'm talking about to make it all come together, in a nutshell, it's communication, but we're also talking about site safety, cost tracking, resource management, all the things a project manager would do when they're constructing a project. A lot of the time, a construction manager is also a civil engineer, or they can be a civil engineer as well. This is just a little excerpt of a construction schedule called the Gantt chart, just showing various activities right here, and then in bar chart form, showing where those activities take place with respect to the other activities and the durations of those various tasks. Now, this is an example of a consulting project I worked on. And in this case, the construction manager hired our firm. I do consulting, as Dr. Shimabuku mentioned. Some of us do consulting, some of us do research, many of us do both. This was a project that a construction manager wanted us to look at a couple of things. And that is for a new hospital, which is right in this area here. Wish my cursor was just a little bit bigger. But this is the new hospital, and it comes around here. They were wondering about how to position these cranes so that this hospital could be constructed. So that involved looking at the zone of crane reach to see where these cranes can swing. And also we had to think about the crane pads themselves. So it's something that we don't normally think of, but the crane pads have to be strong enough to support the cranes so that we can maintain site safety and build the facility. And so cranes usually have outriggers of some type to help support it. You can imagine if a crane is holding a load positioned like this, these outriggers here shown in red would have the most pressure on the ground. Pressure being a force divided by an area. So there's a force coming down divided by this area over that pad. And so we don't want to overstress the soil in those areas. Now, different types of soil have different amounts of pressure that you can put on the soil, ranging from hard rock to wet clay. And again, we need to keep these pressures below a certain allowable pressure, which is again a force divided by an area. We even have to think about the geometry of the site. So here's a side view or a profile view. If we put a load here on this outrigger, because we have this little embankment here, we can push the sand out or the soil out more easily in that case, and that needs to be taken into account. And things like this can happen. These were bearing capacity failures on these cranes. This one has outriggers. This was just one on tracks, but it had a bearing capacity failure at the front end. And usually when a crane starts to sink into the ground, it's usually not a good thing. It usually goes over very quickly. It's very dangerous. And so this is an excerpt of the actual notes that I gave to my design team in my consulting firm. And later we converted these to a CAD file for our client, showing the design of the crane pad. And so some of those things were taken into account concerning bearing capacity. And so again, these are the various things that come to mind for me when it comes to making it all come together from a construction or a project management standpoint. And I like to refer to these things as people-person skills. And To me, that's what makes civil engineering so exciting. It's not just drawing up plans, it's actually drawing up plans for the public, for your client. You're working with people. And that's what adds a lot of richness to the profession for me. And I think that's why you've made a good choice with civil engineering.
I'm one of a team of 3 within the specialty of structural engineering, so I'll be representing my colleagues here, Dr. Paul Nowak and Dr. Sarah Ganserly. So what I'd like to do is, one, thank you for being here, and I'd just like to talk about really 2 things, one of which you already know, I think. So one of those is the what is structural engineering, and I think a fair number of you have some intuitive idea because you've been in a building, you've seen a building, you've dealt with structures, and so you're at least somewhat familiar with what structural engineering is. It's somewhat intuitive there. But then what I want to focus in on more so is the why. One, why am I so excited about structural engineering as a specialty and structural engineering within the context of Gonzaga University, which I think is really quite a special place. So I'd like to just give you an overview of some examples of projects, and in fact, examples of projects that I've been working on during my career, in part to show you just how much sort of the wide applicability of what you can do with civil engineering and the specialty of structural engineering. So I've had a chance to work on everything from mega tall, so that's you're looking at the skyline of Dubai right here with the Burj Khalifa. So where that's looking at, that's about 2,700 feet tall, all the way down to micro small, so micro cantilevers that are maybe 25 microns in length, and everything in between. So whether it's a water treatment center, a dam, a bridge, a building, housing, or even satellites that are out in space, things like that, all require some level of structural engineering to make sure that the structure can deliver what it needs to. During and everything in between, like I was saying there. So some examples of this, here's a 32-story building that I worked on, again in Dubai. It's a headquarter, and what's really neat there is there's that cantilever all the way over on the top story, and in the middle there you see this little glass ball, and that's where the chairman and the committee of the Mashroq Bank actually hold their quarterly meetings. So that was kind of interesting to design. And then you see over in China, we had the opportunity to work on an optimized structure. So this is a very high seismic zone and a very tall building. And so what we did was we came up with structural bracing, and we iterated over a whole bunch of different designs until we finally came up with the optimal solution that allowed us to both deliver a very tall building, but also one that was very sustainable in addition to being able to withstand very high seismic forces. Closer here to home, I've had the opportunity, 2 of my specialties are with composite materials. So working with laminated glass. So I don't know if you're familiar with this company at all, but they dabble in technology. And so I've had an opportunity to work on some of their headquarters. So designing the Apple Store in glass. There's a series of very large glass staircases. And then if we go over to the West Coast, I don't know if anyone on the call is from California and specifically LA, but you've got the Sky Slide. So up there, about 1,000 feet up in the air, you can slide off the side of that building. And if you trust my engineering, you'll have hopefully an exciting but a good experience sliding down those couple of stories here. So in addition to that, more recently, like Dr. Mazinski, working with consulting, where I had an opportunity to work on facades for the Milwaukee Bucks. I'm originally from the Midwest, and so that's a new stadium that the city of Milwaukee and actually the state writ large is helping to pay off right now. And closer to home here in Spokane, we've got a lot of cross-laminated timber. It's just like glass in the sense that it's a composite material, highly sustainable. And so we've been working both with Kateria, which is a very large company, and also Vaughan, which is another company that's very close by here, to come up with a series of solutions that gives you sustainable options. And the reason that this is so exciting to me is because very early on in my career, I really enjoyed working with wood, building with wood, building even forts in the back of my yard. And so I've had an opportunity to work at large firms in Chicago where we dealt with high-rise buildings made out of wood. And then, like I said, it's not just for me about building buildings and coming up with new solutions and things like that, but really what's fulfilling, right? What do you get excited about? Because hopefully you're choosing engineering because that's something that's exciting to you. And so for me, what it was an opportunity to, would you believe that that's an actual fort that I built growing up? It's not, but so growing up, I really enjoyed building tree forts. And so now actually I also have the opportunity, that's probably more what they look like. And now I have the opportunity to build those with my daughter and now my son as well. And the thing that really inspires me beyond all that, beyond being able to design these buildings out of sustainable materials, is this idea of engineering, civil engineering writ large and structural engineering in specific, as an opportunity to have a positive impact on our society and on our planet. So the whole point of being able to do more with less as an engineer. So limited resources in the world, but we're a world that needs to grow, right? There's going to be more and more people. So how do we effectively house those people? We have limited wealth, but we want to continue to create value. And sometimes we're a world of irresponsible excess. But we also want to be able to have dreams and inspiration. And so I think as engineers, specifically civil engineers, we're poised to uniquely be able to execute on these things. And so that's very exciting for me. Just a real quick thing, obviously you're probably all familiar with, there's more people on the planet. Every day we go along, there's more and more people. And so go back as far as you want, all the way to modern times, we've had a huge increase of people. Which is an exciting reality to live in. But the question is, what do we do with all those people? So as you look at the United States, for example, increasingly, as our population goes up, more and more and more of those people are living in cities, in urban areas. And so as you look at, for example, the population in 2019, we had about 7.7 billion people. About half of them lived in cities. You fast forward to 2050, we're predicting to add about 3.5 billion people, or I'm sorry, 4 billion people, and almost all of them, 75% of them, are going to be in cities. So how do we put all these people efficiently into cities? Well, here's the skyline of Chicago, where I worked for several years. And so this tall building right here, as all of you budding engineers will know, is the Hancock Tower. But what we want to focus in on is actually this building right here, which is the Chestnut DeWitt building. And so if we could build at this density, and if we could figure out how to do that efficiently, we would be able to optimize our cities to be sustainable and also be livable. You'd enjoy living in them. And what's exciting for me specifically as a structural engineer, just to finish up here, is this idea of, as structural engineers, we get one shot. From day one of your building, so if you look at the life cycle of a building over 50 or 100 years, 80% of that is your heating, your electrical, your light bulbs, all that kind of stuff. But on day one of the building, right when you hand over the keys to the new owner, there's going to be 15% of 20%. So that's 75% of your embodied energy is associated with the structure. And so later down the road, you can always switch out your light bulbs to be efficient and all this kind of stuff, but you can't switch out your building structure. You get one shot at that to be efficient. And so that's what's really exciting for me, and really ultimately how I see an opportunity to make a significant impact going forward. So day one, you've got 75% of that embodied energy is in the structure. So I have one shot to make a big difference. So with that, I just like to point out that here, one of the things that really excites me about Gonzaga is working both with colleagues like Dr. Mazinski here, as well as students. So we've had the opportunity to look at how you can utilize structural engineering and geotechnical engineering with a student to come up with affordable housing options. How you can use cross-laminated timber, again, Seth is a former student of ours, to come up with unique housing solutions. So all that's very exciting. I get excited about engineering, but I also am really looking forward to the chance to work with you.
a little bit about my background. I was a consulting engineer for about a dozen years before I went into academics, and I actually ran a graduate program for about a dozen years before I finally got my dream job at Gonzaga. Transportation engineering is thinking about how we plan for the transportation system. So a lot of similarities to what Dr. Schultz was talking about, and thinking about, you know, energy usage. Certainly we use a lot of energy in moving people and goods around. And then designing the facility. So how does the facility actually work, the engineering, you know, and working with the construction, like Dr. Mazinski said. And then my field is more in the operations side. So how do we operate the facility? And in particular, what's exciting is thinking about emerging technologies. So I do a lot of research in a field called connected vehicle technology, which is how we can use vehicle communications to operate our system more safely. And so I work on a project that's one of only 3 pilot deployment projects of this technology by the US Department of Transportation. And so we have a 400-mile corridor that experiences a lot of freight traffic and very high crash rates and really severe weather. And so we're looking at how technology can really improve the efficiency, but most importantly, reduce the number of serious and fatal crashes. So for the last 5 years, we've been working with vendors, deploying technology, making sure that instrumentation that we put in these freight trucks does not cause distraction. And what's been exciting is I've been able to really involve students here at Gonzaga. So we go out to the corridor, we work with the agencies, and usually have kind of a subset of the problem. And we also work with research institutions. So looking at, we see some pictures here of my Gonzaga students working in driver simulators. So we need to really make sure that we test this technology out before we implement it in the vehicles. And so there's a lot of driver simulator training where you can look at eye pass and level of distraction, but also make sure that the information that they're getting in their cab is something that they understand and is actionable. So that's been an exciting project that will keep going. And so on the other end of the spectrum is I also do a lot of work in what we call active transportation. So how we can look at our urban areas to encourage other modes of transportation besides vehicles. So here's a bunch of pictures on, you know, promotion of bike facilities and pedestrian facilities and sort of walkability. There's lots of reasons beyond energy and safety. There's public health reasons. There's also a lot of social equity issues involved with that. So some of the things that working in the community of Spokane with my students, we go out in the field and we build pop-up infrastructure. So here we're doing a test of a cycle track right adjacent to campus, and we put this out in the field, and the students got to not only like hands-on paint using temporary paint, but we also did a lot of evaluations of that. Sometimes I want them to think beyond facilities that they might be have experience with. So we'll hook things up to VR, and that student is riding the streets of Copenhagen and seeing what different types of transportation systems can feel like. And then we do lots and lots of analysis, and this is just one of the examples we did of looking at some commute options here in Spokane. So the last thing I want to talk about is related to transportation, but actually related to all of civil engineering. And it's this belief that I have and that the faculty here at Gonzaga have, and that a civil engineering degree is really a degree that empowers you to have profound impact on the world. And so one of the things that we do is we, through our study abroad program, is we take students to the Netherlands. And so Delft is a city about an hour south of Amsterdam, but also has a major technical university and lots of innovative research going on. And we spend 3 weeks looking at sustainability in practice. So not just, you know, in the books and, you know, looking at, you know, sort of reading papers and whatnot, but we go and experience it. And so lots about transportation, but lots about water, net zero buildings. We looked at food production and we saw, you know, the efficiencies that they're getting out of their greenhouse districts and how a tiny little country like Netherlands can essentially export food to all of Europe. So anyway, that's just one of the examples. So we do this every other summer.
I'm Dr. Sue, and I do my area of research in water resources engineering, or basically have done a lot of work in water resources, had some consulting experience where I got exposed to river restoration, stream restoration techniques, which I'll talk about in a little bit, but it sort of inspired me to sort of learn more in the area of water resources. And also a colleague of mine, Dr. Noel Borman, is also affiliated here with us in water resources area. And so I originally got involved with with water resources. Actually, when I was an undergrad, I was trying to figure out what kind of area of engineering do I want to go into. So I was halfway through my undergrad program and needed to sort of focus in on an engineering. Particularly, I thought civil engineering, but then I was like, well, which area of civil engineering? Because as you've noticed, we have all of these different subdisciplines. And I got to shadow a hydraulic engineer who was designing a fish ladder for a dam on the Delaware River. And I was like, you can design ladders for fish? I'm like, that's what I want to do. And so it really got me immersed in the area of rivers, in the area of water resources, and knew I really wanted to hone in on that particular area. And so water resources engineering, basically we design systems that deal with water, going back to what Dr. Shimabuku talked about with water distribution systems. So it's about designing water distribution systems for drinking water, to get drinking water out there, for irrigation, for flood control, power generation, hydroelectric dams, so on and so forth, and generating power, and also for recreational uses. And then basically I dove into a number of different areas, and particularly stormwater management. So one of the systems that we do tend to look at as water resources engineers is managing the water when it rains. Right? So when water falls on pavement and sort of impervious surfaces, right, that's generated as surface water runoff. And the traditional way that we manage that stormwater is, which I'm sure you've seen if you've driven down a road or rode your bike down a road, essentially it funnels into a curb and gutter, goes into an inlet and then essentially into stormwater pipes that then head directly to the river. And so ultimately we don't get to treat that stormwater runoff. And so there's new and innovative and more modern techniques to look at managing stormwater runoff, and that's through infiltration. So low impact development techniques, which are a bit more sustainable and also act to treat that stormwater runoff, sort of filter it, remove some of the oils and greases and metals and that come off of the roadway surface. And one of the fun research projects that I got to work on here with the city of Spokane is permeable pavement. So paving our roadways with asphalt and concrete that is permeable, that allows the water to filtrate down through it, infiltrate down through it and into the ground below, and ultimately getting filtered and treated as it percolates down into the water table, and sort of recharges our water table as well, which is our water supply system here for Spokane. And so there's a street on the northern end of our campus called Sharp Avenue that the city was looking to repave with pavement, and they wanted to use permeable pavement and also tested how effective it was at infiltrating and treating the water. And so we had 15 students involved, the summer research project, 2 senior design teams that were involved with designing this pavement as well as the monitoring system to see how effective it is. So this is just one aspect of stormwater management, and in particular water resources that really helps on the more sustainable side of managing water. And now I'm going to talk to you a little bit about rivers. And so rivers and restoring rivers. And so, and in particular, my fun little friend here, who is the original ecosystem engineer, the Beaver. And so river restoration is about taking a river that has been destabilized, has too much sediment in it, maybe too much nitrogen, phosphorus, so on and so forth, and trying to restore it back to what it was prior to disturbance. And so in river restoration, a big area currently, and the one that I focus heavily in on, is using Beaver to help us do that. So reintroducing Beaver into our watershed systems and their dams. And in particular, the dams that Beaver build are great for the ecosystem. They tend to pond water and store water, retain water in the watershed, feed the vegetation to keep it nice and green and growing, and then also filter out sediment and nitrogen and phosphorus, spread the water out to reduce energy so that sediment falls out. And so dams and Beaver in particular are really great at restoring and improving and making a river system more resilient. And in particular, there's some research that's going on about in watersheds that have quite a bit of beaver in them and beaver activity in them, can they be more resilient and resistant to wildfire? So we've had lots of wildfires here in Washington. If you're in California, you are very familiar with the wildfires that are there as well. And so looking at keeping beaver in our systems and their dams and the water that they retain, right, can help protect from wildfire damage. And also, in addition, if we cannot get beaver back in a given system, we know their dams are very beneficial for the ecosystem. And so what we're working on doing is simulating beaver dams. And so these are known as beaver dam analogs. And I've had a project ongoing here for about 5 years where in Hangman Creek watershed here in Spokane, this is Hangman Creek coming into the Spokane River. And you can see, hopefully you can see, that essentially Hangman Creek carries a lot of sediment, right? All this brown mud, right, coming into the Spokane River. And we are looking for ways at reducing the amount of sediment moving through this system. And we feel strongly that beaver dams, simulated beaver dams or beaver dam analogs are a great way, best management practice to manage that sediment coming through the system. So we've implemented beaver dam analogs on tributaries to Hangman Creek. And basically they are posts pounded into the ground where you weave vegetation between those posts to simulate an actual beaver dam and then get the same response from a natural beaver dam. And then hopefully eventually the beaver will move back in, take over our constructed simulated dams and run with it, right? And then actually do the things that they do that make nature better. And so ultimately these are pictures. I've had a lot of students involved out in the rivers, building the beaver dam analogs, monitoring their effectiveness, so on and so forth. And then the last thing I'll talk about here were related to water resources, and in particular, it also ties back into my Beaver Dam analog project, and that is using drones to help with the monitoring process. So unmanned aerial vehicles or drones, we can use them particularly for monitoring rivers under high floods, right? So when we have a very high flood stage, it's really unsafe to get in the river at that time. But we can learn a lot from what the river looks like, how it's flowing, the hydraulics, so on and so forth. So if we can use a drone to fly over the river and capture that, either aerial photos or videos, we can use that to help better design river systems, bridges, Beaver Dam analogs, if that's what you have in your system, right? And then in addition, there's new technology out there that's called structure from motion, and it builds off of old surveying techniques called aerial photogrammetry, whereas if we fly the drone in a specific pattern over the river and take a whole bunch of photos, overlap those photos, we can actually create 3D models of the ground surface from those photos, or basically digital elevation models. And so if we basically just by flying over, and it is much more efficient at doing that than getting out there with a rod and level and survey and having on the ground measurements. And so I've had students in the past look at using the drone to capture the images and create the 3D models to use in monitoring my Beaver Dam analog projects, but also just seeing how well the technology works and where else we can apply it. And so as I can reiterate from everyone else that spoke here, we love to get students involved in all of the projects that we work on, particularly undergrads. And I'll say the stream restoration area isn't something typically an undergraduate student will dive into. Usually it's more at the graduate level, but I love the opportunity to bring my undergraduate students in and really get their feet wet. Let's quick talk about hands-on opportunities here, that if you are a Gonzaga student, and particularly in civil engineering, that we have a variety of opportunities where you actually can get your hands-on opportunities at building things, designing things, working with other students and other organizations, so on and so forth. We have the American Society of Civil Engineers student chapter, where you can build, and two of the clubs that are associated with that include Steel Bridge and Concrete Canoe. So designing and building and racing a canoe made out of concrete, and then also creating a steel bridge that gets loaded, and competition. Basically, there's competitions at the regional ASCE student chapters where we all compete against other schools, how much our steel bridges can handle, and then also how fast our concrete canoes can go, right? There's also Institute of Transportation Engineers, the Society of Women Engineers, Zags Without Borders, which is like Engineers Without Borders. It's sort of our school's chapter. And then there's also Sustainability Club and some other opportunities to get in there. We also get our students out into working with elementary school students and doing STEM activities to inspire elementary school kids in engineering or in the STEM fields. We also have a great time with a bunch of social activities, both with the faculty and the students participating. This is a picture from our volleyball tournament that we have all 4 levels of freshmen, sophomores, juniors, and seniors competing against each other, and then the winner goes against the faculty. And one of these days, we might actually win that game, but I don't know if that'll happen. Faculty needs a little help with volleyball, but so on and so forth. So anyway, there's plenty of opportunity to get your hands dirty in civil engineering here at Gonzaga.
I am the advisor for the Society of Women Engineers, and no matter whether you participate in that chapter or in some other chapters like Gonzaga, our student chapters are very, very active and engaged in the community. They do a lot of service projects, and that's very admirable. Also, the chapters help you out connecting with the reality of Spokane, because Spokane is well represented as far as industries, although we're not a huge city, but we have a very nice presence as far as corporations. And our industries are not just local, they also have sites elsewhere. That's a very nice opportunity for you to get involved.
Most of students and would do their internships between their junior and senior year. I would say about 85-90% of our students are finding those internships. And then between the sophomore and junior year, it's increasing. I would say a third to a half of the students are seeking internships there. And we get a handful that do it between their freshman and their sophomore year, but it kind of ramps up. And that's where we see so many students by the time of graduation having multiple internships, because they're looking, maybe they might do a private side versus a public agency, and they can really see different pieces. But
what can you do to help students connect to internships? Or what does Gonzaga do?
Yeah, so Gonzaga has, I would say there's two things. We have a career and professional development center, and they use a program called Handshake, and that's where everything gets posted. But a huge resource is the faculty. All of our faculty are very engaged out in the profession, working with companies, working in consulting, working on public agency boards, that most of those jobs that are being put up on Handshake are actually coming to the faculty first, and then we're passing them on, because we're just faculty that are very engaged. And so I always ask my students, what is their dream job? Where do they want to be? And I view it as my role to help figure out how that can happen. So anybody else?
May I also add that we do have a career fair that's aimed strictly at engineering and computer science. And there's an opportunity to network with them. So you don't have to say, oh, I shouldn't go to that because I'm just a first-year student. You're welcome to attend that and see the variety of the employers that show up. But the other thing is actually working with the faculty. And this is a very modest faculty. They did mention they just love to have students working with them. But once you get to work with them, maybe in some form of undergraduate research with them, they get to understand what you know how to do, what your passions are, what their passions are. And that also helps them to, for lack of a better word, hook you up with somebody out there who may be interested in giving you an internship. So many ways for you to interact with the faculty in order for them to help you find that right connection.
That's present in a couple of our classes. One in particular is called Civil Engineering Design and Practice, and that's one where we talk money matters, among other things. We talk about some of the soft skills of engineering in there, so-called soft skills, including, well, communication is present in just about every class I can think of, but we talk about engineering law, ethics, project management, and the engineering econ as well. And so it is important if you're in a private engineering firm, of course you want to stay in business, and so that comes in. You need to make enough to make the target profits, pay your employees, and with that you can always give back to the community. If you're in the public sector, in say a Department of Transportation or a municipality, you need to stay within your budgets. And so it is very important. And that's one of the classes that we talk about that. Some of our students do business minors as well. I would say not a very big percentage, but you have that option. In my opinion, you learn what you need to know without the business minor, but that option is always there. But I would say that we cover the money matters in your junior year in the course that I described.
I would just add on really quick, I teach a class called Sustainable Systems and Design, and that doesn't just focus on environmental sustainability, but also economic sustainability. So we incorporate a lot of the concepts that Dr. Mazinski is talking about, and looking about the sustainability of a project from using the three pillars, environmental sustainability, social sustainability, and that real critical piece, the economic sustainability.
A lot of the faculty spoke to the fact that they worked before they came to academia, so they're bringing experience, and they worked in for-profit industries. How many of them really decided to go and get a business minor in order to be able to do that? Maybe none of you will raise your hands. But I think Dr. Mazinski is correct that you don't really have to go to the business school to really acquire the business skills that you need. And sometimes acquiring the business skill set within the context of business may not be appropriate for acquiring the business skill in the context of being a civil engineer. So I would root for Dr. Mazinski that go get that on-the-job training.
Dr. Dory, who is not here, but who is a member of our faculty, is been the sort of the primary person involved in the engineering LLC. And I know she's been working, kind of their big effort throughout the year has been toy adaptations. So that they get toys donated, and then they work with the community in finding ways that they can adapt those toys to children in need who might have special needs and whatnot. I know that's a big project. And then she's also, her and I know Dr. Shimabuku has been involved as well, is in the Center for Community Engagement. And so there's Gonzaga as a campus is really rooted in the community that we live in. And so there's a big initiative with working with underserved parts of our community. And that can be, after school programs, cleanup days, and all that. But with Dr. Dory and Shimabuku and myself, we're also working to do more with the engineering side. So, in transportation, one of the things that came out is this is one of the highest poverty zip codes in the state of Washington. And they have pretty serious issues with, housing security and food security. And I know Dr. Mazinski's worked on affordable housing, and so has Dr. Schultz. But transportation is their third largest concern, that the safety or the ability of their kids to sort of walk and play and get to school and stuff. So getting the students involved in walking school bus programs, and our students designed a bike boulevard or greenway that's being built through campus. So it's ultimately going to be a $1.2 million project that gets built, and so the students got to design that. So so that engineering, the LLC is doing projects, but it's all like combined with all these efforts that it's kind of hard sometimes to just draw the line. But I know that toy adaptation is kind of their big flagship program.
They are open to working with you, with any students, especially the ones who live in the LLC. The residence directors, the residence assistants who live there, they are anxious to hear what the students have to say, what the students would like to pursue, and can work with you on making something happen.
I think the neat thing about Gonzaga, which is remarkably different than a lot of other schools, partially because of our size, and then also partially because of our mission, is that you have an inordinately large ability to shape your directions in engineering. And so, like, when could you do an internship? I think if you were interested in doing it, you could do it with our help immediately your freshman year, if that's right for you. If you weren't interested in that, I think you could do something else. You could do research over the summer. You could do different things like that. So, and same thing with engagement, right? So there's going to be optional engagement, and then there's going to be, depending on what courses you take, for example, the senior structures, we're engaging and we're doing a historic building survey for the city, right? And so you're utilizing your knowledge that you're gaining in class and you're doing that for the city. And because you have a client that is the city, just because you're operating from home this semester, you still have to deliver that. And that's incumbent on your professor to figure out how to make that happen this semester. But that's a whole different story. So I just wanted to point out that at Gonzaga, I really think there's that ability to shape your experience in a much more profound way than some like giant state school or something like that.
If you come to Gonzaga, what you find here is a community. And I think that's transparent from the students' point of view, from the faculty point of view, the staff point of view. It is like the connections that make this place very, very special.
Ultimately, as a civil engineering student, you get coverage in all 5 areas. So you get the breadth throughout your curriculum, you get the breadth across all 5 areas. So you do come to understand each of those areas. But then in your senior year, mostly your senior year, you have the opportunity to take 4 technical elective classes. So 4 elective classes, and we offer a variety of those elective classes in all 5 disciplines, and it allows you to sort of maybe focus more on one. So you could take 4 of those electives in one of the subdisciplines if one really excited you, or you could take one in each if they all excite you, right? But you get an opportunity to sort of emphasize, I guess you'd say, in your senior year when you get to take those electives. But then up till that point, you get introduced to all 5 of the subdisciplines along the way, because it is a civil engineering degree that you get out of this in the end.
Yeah, so we've decided to leave the flexibility up to the students, because in some institutions have decided to do tracks, and we just provide the space for you to design your own track. So depending on, some students want to stay broad. A lot of it can be, I mean, one of the nice things about being a civil engineer is you might want to go and live in a small town, and then it might be beneficial to stay broad and be sort of or you might want to only do, transportation, of course, but, and then you go deep in that. And so we let students, but we through the junior year, we provide that breadth, and then we work with them, because you have faculty advisors that sort of say, well, what are you thinking? You've gotten this exposure, is one resonating? Where are you at? And then we develop the curriculum for you. So we don't predefine it into tracks.
In your senior year too, you do a capstone senior design class. So it's one big project for a real world client that you work on throughout the entire year of your senior year. And usually those projects are a little bit more sub-discipline focused. So there'll be a more water focused project or more transportation focused project. So that can give you immersing yourself in a real project for a full year, sort of in that sub-discipline, which might also have a couple of the other sub-disciplines tied to it, but it's another opportunity to get more emphasis in the one area.
And in teams of 4, so so you are not a member of a large team, so there's no being a wallflower.
How can a student get involved in research at Gonzaga with civil engineering? I mean, how does a student start?
Slightest bit of interest. That's all it takes. The slightest interest, and then we're off and running.
Usually it comes from those classes where you're learning about our discipline, and if you show an interest and then they reach out, yeah, you can't hide at Gonzaga.
I'd like to add that another way to do that is when you choose civil engineering as a major, you are assigned to one of the faculty to advise you. That faculty is not just advising about your curriculum, but they'll advise you in your career and help to grow the interest that you have in a certain subject area. That's another thing this university provides that other large universities don't have the time to provide. It's that one-on-one advising. And I'll stop and hope Dr. Young will pick up and say something more about how that works in civil engineering.
Yeah, I mean, one of the challenges we have, because we all are, professionally and research active, and so Dr. Schultz alluded to show a bit of interest, and we'll grab you. We actually have a hard time finding enough students because we also have an incredibly strong job market and all these internships, and so I would say the students are blessed with a wealth of choice, and so. We through our advising appointments, we start to see certain students show an interest in graduate school. Those ones for sure, we say, you should probably get involved in a research project and do that. And so it's just one of the things we all have very different personalities. That came out, but all students find someone, a faculty member that they resonate with, and everyone, it just works out. It's great. And so there's always one faculty member that really understands the sort of the career path or the sort of, hopes and wishes of every student. And we're just looking for opportunities both within our own programs, thinking about graduate programs at other schools, and our contacts out in the profession. And it, that's a huge benefit of going to a program where you are not just your name is known, but your hopes and wishes and career paths and everything. You can't get rid of us.
Now, from a housekeeping or logistical perspective, though, we're typically assigned some advisees, but you're always free to change it up. So you're assigned one of us to be your advisor. I've had advisees come to see me, though, with a form in their hands, and they say, I want to switch to Dr. Sue as my advisor. And my feelings are hurt initially until I realized that Dr. Sue is much better suited to that person, or vice versa. So you have that ability to change as well. But I think a better thing might be just to consider all of us as your advisors. You'll have an official advisor, but feel free to come see all of us in various ways. I think all of our doors are open to everyone.
And one thing that's nice is it doesn't end at graduation, that we still have contact, and students will reach out and said, I did this, I went this path, and I had this one project that was in this area and it really sparked something, and I'm looking to change that. We still have a lot of contact, and we know, and then our students come back to the career fair, and it's a circle. Then our new students go and work for our old students, and it's great.
It's really fun seeing them at the career fair.